Okay, here's part two, just taking off from where we left off here. Let's add some chop references here. So if you look at torus, or maybe this rotation of the geo right here that we liked here, maybe on the X or on the Z. Let's see what happens on the Y. That's cool. Let's do that. By the way, I think I spoke briefly in the first videos about this, but an easy way to kind of scrub through values here in the parameters, I'm clicking my middle mouse button, holding it down, and this gives me what's called a value ladder from 10. It's like basically magnitudes of 10 going down. So let's say I want to change this parameter in increments of 1. I go up here, and now I'm still holding the middle mouse down. Now I go to the left, it goes down, and then I go to the right. And then when I release the middle mouse, it kind of goes back. So this is a quick way to kind of scrub through. So if I want to go in increments of 10, I go up here and then go left and right, or very, very, very small increments. And this is going to be not even visible at all. So this is really helpful to just kind of change values for parameters. So I want to add a chop that's going to maybe make this torus do a little wobbly oscillation there. So let's do that. Let's add, that's our little friend, the LFO. Great. And move over. And let's go ahead and do this on the geo because we've got the rotate there. I could do this in a couple places. I could also add a transform SOP and do that right here. You can see that. In general, if we can get away with it, preferably it's good to do things like translate, rotate, scale type of stuff, to do that on the geo and not on a transform SOP. That is because I talked before about these geometries are becoming pixels. Once we're dealing with tops, then the GPU is handling all of the computation, which is highly efficient and fast and amazing compared to the CPU computation. So all of this SOP stuff is being calculated on the CPU because we've got C display. Let's look all the points. So the CPU has to take a turn, has to calculate, okay, what's the position of this point, this frame? What's the position of this point? And then what's the position of this point? And so it goes in order in a serial fashion and calculates the positions of all of these things. Whereas on a GPU, it kind of just calculates all pixels simultaneously, essentially. So what that means is if I'm, hook up an LFO or whatever to this, and this is changing every single frame, that's putting extra work on the CPU to, on every frame, it has to recalculate the position of all of those points. But if we do it on the geo is a kind of like middle bridge between the CPU and the GPU, and so it's actually utilizing hardware acceleration, GPU acceleration to calculate all of these points. So it can, in a bigger project, it will definitely lead to more optimized frame rate. So it's just good to get in the habit of doing that here. Oops. You can, if I had it before when I had these box and things going in, and if there are two things in one geo and I only want the torus to rotate, let's say, then of course, then you really have to just put the transform SOP there and just deal with it. But whenever you can, do it on the geo. Okay, so do the standard thing here. Do rotate, if you're active, drag it over, chop reference, great. And that is just the tiniest little wobble because I'm dealing with degrees and this is only going plus to minus 1. So let's do 100, and that's too fast. Okay, cool. Okay, that's fine. So that's going to wobble. It's going to do a little sine wave oscillation there. That's cool. Let's do the same thing with this box. So let's say I want, instead of a sine wave, I want it to just completely rotate around. So in that case, I could do like a ramp, maybe amplitude 360. And so what it's going to do is go up to 360 and jump to 0, go up to 360, jump to 0. And again, helpful tool, get a trail chop, hook that up, and this is just really good for debugging, so I can kind of see what the shape of that data is. So it's a ramp, or also called a sawtooth wave. And then let's do Y. There we go, okay. So that's going to be a kind of seamless rotation because it goes from 360 to 0, which is the same value as far as degrees are concerned. Okay, let me show you a different way we could have done that. Oops, that just gives me an error now. Let's get rid of this. So sometimes, you use LFOs, whatever. Other times it's just kind of quicker and a little more slick to just go ahead and write a little bit of Python right here. So we're going to learn one little snippet of Python code. So to do that, we're going to get our parameter, hit the little plus sign. We see the 3 different parameters here. And I want to change RY. So by default, it's on this gray box, which is a constant value. Blue means expression, which is a Python thing. Green is that export thing we don't care about. And this purple thing, I don't know, bind. I've never used that before. I'm sure it's something cool that I don't know about. So let's click on the blue one, and let's write some Python. So a handy little snippet of Python, absolute time dot seconds. So what this does, it gives us the number of seconds since this file has been opened. So I've had this open for 4,500 some seconds, whatever. And so it's using this for rotation. It's very, very slow, but we could do something like just times it by something, whatever, cool. And this number is super huge. As far as rotation is concerned, it doesn't matter. It's just, it eventually gets kind of divided down from like 0 to 360, so it doesn't matter. For a long-term installation, this could be a problem if you have a computer running for a week, because eventually it reaches a number which is higher than the computer can actually process, and everything will crash. And so you have to kind of figure out a workaround for that for long-term installations, but we don't have to worry about that. Okay, so that's using an LFO down there, a little bit of Python here, absolute time. Let's look at our handy little noise again. Let's do like another noise thing. I want to modulate the dimmer thing here, like make a little horror movie, like the lighting is broke or something type of effect. So let's do something like, so I know on my light, like 0 is basically the lowest it can get. Like numbers below 0 don't really matter. And maybe I want it to go up to like 2-ish is kind of bright. I mean, I could go like up to 10. I mean, that's like totally blown out. So whatever your style is, cool. So then I'm going to kind of shape my noise to basically be between 0 and 2. So, I mean, there's various ways we can do that. We could play around with different types of noise. I think Alligator has this kind of shape where it kind of hangs around 0. I can make amplitude more, something like that. Change the C, change the period, like whatever. Let's see what that looks like. Okay. So that has a certain visual effect. And then as you kind of, shape this data, like I always talk about, kind of like you're in ceramics class, let's like shape it. Let's say this feels a little bit too jittery for me. So let's do like maybe a big period. And then maybe even like a bigger amplitude, something like that. Right? So it has a very different feel to it. So you kind of just shape that data however you want. I mean, we could do like, so random is like completely insane. Brownian. So this also goes kind of below. So I could do something like, let's do offset 2, amplitude 2. Try different seeds until it kind of looks the way you want it to look. But that's not what I want. Maybe like offset 1. So that's a much slower kind of contour. Okay, I'm cool with that. So many different things you could do. Lots and lots of different chop references. We could reference all over town and do all kinds of things. These other kind of modifiers I didn't show before. As far as like what ones we want to use off the bat. I'd say noise, maybe noise, twist, and wire are kind of cool. Let's just kind of see what they do. Let's do a box. Let me hook up wire to this one. And we could see wire converted this into a kind of wireframey looking thing. Let's make this a little smaller. So that's kind of cool. All right, I like it. What does noise do? Oh, that's weird. I actually didn't expect it. So the wireframe kind of like did something weird. So the noise is just basically like taking the little points in there. So let's do something. I want to bypass wireframe for now. So I hit this little bypass that disables this. So now it's not even doing anything. It just kind of just passes that signal along to my noise, and I can see what the noise is doing over here. Similar parameters to all like noise top and noise chop. Cool. If I look at transform, it's actually by default, it has this absolute time, not seconds, on the TZ. So that's why it's animating. So by default, it'll be something more like, just kind of static and not really moving. So basically what it's doing is it's taking all of the points of my box. I've got 24 points, and it's kind of giving it a random XYZ translate to move those around. Cool, okay. I mean, I could kind of leave that translate there. Let me make this a little bit slower. Times 0.1. So it's still moving with time, but then it's just a much slower progression. Okay, what if I did this the other way? So let's do box to noise, noise to wireframe, and then wireframe into geo. Okay, so that's kind of cool. I like that. Okay, cool. What about twist? What does twist do? There's some like really gnarly stuff that we can do with twist. So if we look here, operation, we got twist, bend, shear, taper, linear taper, squash, and stretch. And then change strength. Oh, look at that. Awesome. That's like, becomes like this little putty in your hands. And this can get like super glitchy also, which can be kind of cool sometimes. And by changing pivot, like all this other crazy stuff happens. Okay, so let's do like a bend. Cool. I find with this one, it's like you just play around with the values and you find out some kind of crazy stuff that it does. Let's see. Yeah, that's kind of just disappearing because it's a little bit too extreme. Let's go back. Taper, squash, and stretch. It's cool. So let's do like, okay, there's our twist. And so again, we can do, let's do a little chop reference. Let's do something like, oh, what's one? So we did lots of LFO, lots of noise. Do I want to do that again? What I could do, yeah, pattern is similar to that, except it's basically kind of like an LFO, but it's not changing over time. But as far as the general shape of those, it's essentially the same thing as an LFO. Oh, I got it. Let's do mouse. Mouse in. That's what I want to do. So check that out. I've got TX and TY. And so here I kind of broke the rule. Usually you want to end with a null and then actually do the reference with the null just in case you need to change something upstream. So I'm going to do that here because I think I might want to change something. So let's, I don't know, let's just like put this in here and see what happens. So TY, we'll go to roll off. Okay. So this is doing something. It's very little because my TXTY is normalized to -1 to +1. So I could, so here, like I can't really multiply that, can I? A couple things I can do to this because I want these numbers to be much higher. So here in my expression, I could do something like times 10. And then that works. Cool. Or I could, and this is why you want to do the reference with a null actually. Drag this over, right click, insert, put in a math. And with the math, we can change that range. So on the range tab, this is super useful. So the numbers coming in are -1 to 1. I want those numbers to be 0 to 0 to 10. Sure. Okay. All right, that's cool. So now I'm kind of moving the mouse around and can kind of change how that's being twisted. Cool. Okay, maybe that's good for this one. Let's show one more little thing here. Let's show extrude. So extrude is useful when you have flat geometry with 0 depth. So I've got my text here that I made before. So let's say I don't want polar bear to just be like a flat thing. I want it to have some sort of 3D depth. So I hook that up into my extrude, and you can kind of see what's happening here by default. So the parameters for extrude, values, I think depth scale is what I want here. There we go. Zoom in a little bit. So that's going to make this kind of cool 3D text. Actually, do I have Arial black? I want something just like super fat. Well, let's do this. That one's good. Okay. Okay. Love it. So for any of these, you can use that extrude. Like for this circle, let's say that I did this little arc situation. I can make a more 3D type slice of pie right there. Yep, there you go. And for this, actually maybe ZX, there we go. There you go, there's my pie. So maybe even if I'm doing like a visualization for some sort of infographics pie chart thing. And so now I got this cool little way to show my 3D piece of pie. Cool. All right, that's good for part 2, I think.